Through this recording, I'm going to cover some of the basic concepts in Chapter 3 of your textbook. I'm also using a new recording system. I'm using Adobe Captivate, so I'm hoping this works well. Okay, we'll go ahead and start. Essentially, Chapter 3 discusses I/O streams, or input-output streams. The thing you have to remember when you read your textbook is the word stream really refers to a sequence of characters from some source to a destination. So, for example, an input stream is a sequence of characters from the input device, which is most likely your keyboard or your mouse, and output stream would be a sequence of characters from the computer to a monitor or a printer or to an output device. As you read your textbook, you'll notice that we do use this I/O stream header file, or this is actually a preprocessor file that contains information about the libraries we're going to be using. We essentially discuss two variables, cin and cout. Cin for standard input and cout for standard output, essentially your keyboard and your monitor. And this is why when you open up a C++ file, you usually start with a pound include I/O stream so that all the definitions for objects like cin will be defined. The variable declaration is similar to I stream and O stream. Again, we won't be talking about classes and objects in this class, but CIT 233 we do. Essentially, cin and cout are definition of predefined objects from predefined classes. So I stream, again, input stream, O stream, output stream, and a stream again is a sequence of characters from one place to another place. We use the cin with the extraction operator to accept input. This is one way where you can accept more than one variable from the keyboard. I usually don't like to accept input this way. I like to have a precise prompt through a cout statement, something like cout enter your age, and then cin age. Cout enter your name, and then cin the variable name. So essentially you have variables on this side and then the cin operator on the left side. There is essentially cin, when it reads information, it skips all white space characters, enter keys and spaces. And we'll have a couple of examples here that we'll go over. And depending on the type of data you're trying to read, cin behaves differently. So, and if you enter anything that essentially that the C++ compiler, in this case runtime, doesn't understand, you get an error message. So if you have an integer variable and you try to read in a character or a floating point value with a decimal number, you'll get into what is called an input failure. And input failure in C++ is pretty confusing, because what happens is that it skips all of your following input statements. So if you have a whole bunch of input statements in your program, you get into this input failure, everything breaks. So you got to be very careful in handling errors. Of course, we can handle exceptions through exception handling, which is later. It's a topic that we'll cover later in this class. So be careful when we read characters, doubles or floating point numbers or integers. This is a good example. I think your book does a decent job of explaining this process. Notice you have cin, ch, meaning that you're expecting to read a character. You input the letter A, ch becomes the letter A. Now if you put AB, A, because ch is just one character, the cin only reads one character. And this B is held over for later input. And this is what causes confusions, because if you have an input statement like something that's not accepted, you get into the input failure error. So remember that this B is held for later input. So another input A, of course the way that I have these examples are separate from what you see previously. A is an integer and you're trying to read the character B, so you get into input failure. So if you start seeing your programs behaving abnormally with input, most likely you're getting into input failure when you're assigning a wrong value to a variable. See in A, 48, 48 is read. If you do 46.35, well, 46 is read into A, and then 0.35 is held for later input. So that's something that, again, depending on where you are in your input stream, might cause different behavior. So you get a chance, definitely study these examples. Here you've got Cin, A, Ch, and Z, and this is again what I don't like, why I don't like inputting multiple variables in one Cin statements, because the way you enter data will cause different behavior, or may cause different behavior. So A, Ch, and Z, 57 goes into A. Remember, you're going to go all the way up to the first white space character. A is going to go to Ch, and 26.9 goes here. Now if you say 57A and press the enter key, same thing, because that's a white space character. In this example, A gets 57, Ch gets A and 26.9. 57A, 26.9, same thing. 57, A goes into Ch because you're done reading a integer, and again, you're at the mercy of the C++ machine when you enter data like this. So again, read through some of these slides again. Using predefined functions in a program, of course, we've been using the main program, or the main function, which is the main function, or the first function that gets executed when you run a C++ program. And of course, C++, like other languages, includes tons of functions that, in case of C++, they're organized in these header files. So that's why if you're using a function and you don't have the correct header file, you get in trouble. And essentially, your compiler fails. Now, we'll talk about functions in a lot more detail when we create our own functions. But essentially, the four things that go with any function is the name of the function, the number of parameters it requires, type of each parameter, and what the function does. Of course, with the example of the main, you'll notice this function main right now returns an integer and does not accept any parameters, and essentially it performs a set of instructions given to it. So again, we'll talk about functions when we actually create our own functions. POW is a good example of it's in the CMath library, and obviously it takes two parameters and it returns the first value raised to the power of the second value. So there are a lot of predefined functions that one can use when you start writing your code. We have cin and get functions. The cin.get, this essentially is pretty close to how you read a character, and cin.get varchar, essentially varchar has to be a character variable, and inputs the next character, including a white space. So if there is a white space that you want to read, you'll use the cin.get. Remember, if you use the cin, the regular cin, the white space says are going to be skipped. So cin.get is a good function to use to read character input. Cin.ignore is good when you want to discard a portion of the input, essentially what's left in the input stream, and it comes in handy when we get to dealing with input failures. But essentially it tells you that you can ignore so many characters, or or till you hit this given character. It makes more sense when you see a example of this. So let's keep on going here. Notice you have Cin A. Again, the input is 25. This is your whole input, and you've got two variables. So if you say Cin A is going to be storing the number 25, and then the second statement is telling it to ignore 100 characters on that first line, or till it hits the new line. Of course, there is a new line character right here that we don't see. So what C++ does essentially is ignores everything on that line. So when you read B, B will store 12. So again, why would you want to do something like this? To read something and ignore what's over. Again, it all depends on what it is you want to do. But the cin.ignore is handy in discarding so many characters or until it hits a predefined character. We won't be using it too much in this class, so I think the only place where I'm going to have you use it is in dealing with input failures. Putback and peek functions, again, two functions that you probably have to read on your own and look at the examples. Essentially, putback allows you to put a character extracted by the get function back to the stream. So essentially, like you read a character and you put it back on the input stream. And peek returns the next character from input stream. We probably won't do too many exercises dealing with text data, but these two are pretty handy when you're working with processing text data. So let's just go. I think one of the precautions that they're telling you is that cin.get with a character, cin and get are two separate identifiers separated by a dot. So you're not actually using the extraction operator in this case. Cin is now acting as a object that has a function associated with it. The dot separates the input stream from the function. Again, the dot operator comes in handy when we talk about object-oriented programming. Of course, if you've had an object-oriented programming like Java, you're probably already familiar, well, hopefully you are, with this member access operator being the dot notation. Input failure, again, things can go wrong during the execution. If the input doesn't match any of the corresponding variables, again, the program may run into problems. It all depends on how you're inputting data. Trying to read a letter into an int or double will result into an input failure. If an error occurs when reading data, you get into this failed state, and essentially what happens is that all your subsequent input statements are ignored. So one of the things you could do is you could clear the input stream using the clear function. So once in a failed state, all further I/O statements using that stream are ignored, and the program continues to execute. So that's the problem, because now you're at the mercy of C++ with uninitialized variables. Because if you put in a value into a variable and the input isn't really taken care of, then that variable will have the wrong value in it. And again, you'll note this when you have input statements that is just ignored. So what we do is we could put in the clear function and call it to clear the buffer. And I'll show you an example, by the way, on this when we go to our dev C++ example and kind of talk about, because I do believe I have something about here's how I'm using the clear and the ignore functions. Okay, let's continue on. Cout essentially uses the less than operator to output into the output stream, which is the monitor most likely. And you can also use some precision manipulators. I'm not really too concerned about using these manipulators. They're good to format your output, especially if you're processing, writing programs to create reports on the command console. Most likely, we create reports in files, and we may not really need these things, but it's good to know about them. So you can set the precision. Essentially, if you set precision to 3 decimal numbers with up to 3 decimal places are included or displayed, again, you have to include this IO man IP. And again, now this also depends on compilers. Some compilers may already include these, so you may not have to include these directives. Fixed manipulator, show point, if you want to see the decimal point and the trailing zeros. Set the width if you again want to make sure that your output lines up. Again, I'm not really too concerned with outputting console output data, but it's good to know how they work, but you don't really necessarily have to use them. I may ask you to do one of them at least in one of your exercises, just so you get some practice. You can fill the output so that if you want to fill things with asterisks or dollar symbols or whatever, you can use the set fill manipulator. Notice here they're setting their fill operator is the pound symbol, and you could do left justification, you can do right justification, and you can always disable justification by doing something like this. So in our case, it will be cout dot onset f ios : left, and you're again unsetting the left justification, and you go to the right justification this way. Again, not very important. Types of manipulators, you have set precision, set width, and set fill. And the ones that have parameters, things like fixed or show point, you just have to give them parameters to use them. Now, you'll notice the cin operator. If you're using a string input, if I say cin and have a string variable after it, it will only read up to the first white space character. So if you input in, first space last name using a cin statement, you only end up reading the first name, and the last name will be hanging in the buffer. So if you want to read the entire line, we'll actually use the function getLine. Notice it's not cin.getLine, it's getLine with the parameter cin, comma, and the variable that you're trying to read. So again, same thing. If you're trying to read a whole line and you end up just reading the first part of a name or up to the first character, you know that you're using cin instead of getLine. So you need to use getLine to read an entire line. Debugging, understanding logical errors. Of course, we've talked about syntax errors. Again, syntax errors are easy because they're reported by the compiler. Logical errors are usually never caught by a compiler because the compiler doesn't know about your logic. And again, especially with input failures, you get weird answers. You know that there's something wrong with the logic of the program. Now, Chapter 3 also kind of talks about file input output, but file I/O is really important, or comes in handy when you've done loops, so you could actually read an entire file. But in the example for your homework assignment or the examples in the book, they have you just, if you have 3 lines of data, they'll have you do 3 lines of input. So same idea. Instead of reading from the keyboard, you can actually read data from a file. Instead of displaying output to your output screen or your monitor, you can actually output to a file. And the process is very simple. You have to include fstream header. Notice I did it here because of my example. I'm going to show you how to do a file I/O, so I included that. Then it says declare the file stream variables. Well, that's very important. Notice how I'm doing OF stream with a variable, and I should have a IF stream with a variable. Now, of course, all of these headings or definitions should be at the beginning of the program, but I'm just doing a demo, so as I go, I'll do these for you, but they should really be defined at the beginning of your program. So OF stream file out essentially tells C++ that you're creating a variable name called file out. Of course, this could be anything you like, and its type is OF, which stands for output file stream. And then you'll notice here, IF stream, you have a file in. Again, this could be anything you like. That's just a regular variable. So we have to define our input or output file stream variables. Then you have to associate the file stream variable with the source. Well, you'll notice if I'm going to read, right here I'm doing a file out. Well, if I'm going to output to this file, I have to tell it to open the file. So I'm calling the open function, giving it the name of the file, and then from now on, file out is pointing to this file. Notice the file name has to be inside a pair of quotations, and of course if you have multiple paths, you have to have 2 backslashes, otherwise it will treat this backslash as a literal, and it won't actually open the file properly. By the way, this could actually be an input where you can actually ask the user to tell you the name of the file that you're going to output to, and again we'll talk about that later in this class. And fileout.close essentially closes the connection to that file. So if you notice, the next line is you close the file. So let's go on and see if there's and then there's the summary. So let's go through a little example and kind of walk through this example. Notice I have char ch1 ch2, so I've created 2 variables. Here's cin ch1 ch2. I didn't put a prompt in here, which is not a good idea, but I probably want to say input 2 characters. And I've got this hello, and the program runs. So let's just go ahead and compile this code. I'm just going to compile and run and kind of follow it line by line, and hopefully this thing will come back. I'll go ahead and move this over. Notice again, it's not a good idea. The cursor is just blinking. So I'll put in 2 characters. So I could put 1 and 2. Again, they're characters. Of course, I could put 769, and 769 will just be hanging there. So I'm just going to put 1 and 2. Press enter. Notice character 1 becomes 1, character 2 is 2, and it displays hello. I define a variable called length and initialize it to 0, and then I say length equals length plus 5. Now notice I didn't have to do the initialization, and if I didn't, then length could be anything at the mercy of the compiler. So I enter a value for length is because of this. So if I put in hello for the value of the length and press enter, notice it's actually I'm getting an error message because I'm not getting an error message. It says length equals to 5. Now where did it get 5 from? I put hello in there. Well, what happened is that the value of length was initialized to 0, so it was 0 plus 5. cin.length was ignored, and then it went to the rest of my program. And notice I do have a clear and ignore without this. Let me actually do this for you. So notice this is how it behaves. I'm just going to type 0, press enter. Now what I'm going to do is I'm going to go ahead and close these 2. In other words, I'm not going to clear the buffer, and I'm not going to ignore what's left over in the buffer, and I'm going to compile and run the same exact code and do the same thing, 1 and 2, and then type hello again, or a bunch of string. Notice what happened is that it actually went all the way through this program. It did whatever it had to do. It didn't even let me put in anything else afterwards. It didn't even let me input my my data so that the code could stay there and see what I've done. It just went into the fail state, ignored all the subsequent input and output, and essentially doesn't work well. So I go back in here, I do the clear and compile and run. It'll be just like before. So the clear and run are good to clear the buffers. So now if I put in A space B, for instance, press the enter key, notice the white space is ignored, so CH is A, CH2 becomes B, hello is displayed, and now it says enter value for length. I'm going to put in 10, press enter. Length is 10, it just displays it. Clear and ignore doesn't do anything because we didn't enter into the fail state. Now I have double x equals 1 over 3. So when I display x, it gives you 0.33. Notice this is a default display of the data. Now if I had done set precision with 2, then I would have outputted just 0.33. Set precision, of course, only affects what follows it. So if I did a set precision here, it wouldn't affect that. So see out x is this. Now notice I open a file called, under my one test folder, I have a file called x1.txt, and I'm going to actually write to it. I'm going to say x equals x. So if I go to this folder, one test, x1 text, so let's go to my C drive and go to one test. Here's x1.txt. I'm just going to open it up. Notice it says x equals 0.33. That's because I told it